Let us look at proposition number 3 of works of Archimedes, specifically from on the conoids and spheroids. The proposition has two parts. So let's look at the first part and then we will look at the second part. The first part of the proposition says, if TP and TP prime be two tangents to any conic meeting in T, and if QQ and Q prime be any two chords parallel respectively to TP and TP prime and meeting in O, then QO times OQ is to Q prime O times OQ prime is equal to TP square is to TP prime square. So let's see what this statement is talking about. So we are given a conic, let's say parabola. Let's take any 2 points on that. And here we draw two tangents meeting at a T. So let's get rid of the lines now. And let's take two chords. So we have Q, Q, Q prime, Q prime. And these lines are parallel to the respective tangents. So QQ is parallel to TP and Q prime is parallel to TP prime. And they intersect at O. So now what the proposition is saying is that if this is a setup, then QO times OQ is to Q prime O times OQ prime is equal to TP square is to TP prime square. And here proof is just one statement. This is proved in the elements of conics by Aristeas and Euclid. Now here the tangents can be drawn at any point and this tangent can be also drawn at any point. The only thing is we have to make sure that these two lines Q prime, or rather the chords, actually intersect each other. Similarly, we can take this chord anywhere, and similarly this we can take it anywhere. And the condition is that this chord should be parallel to one of the tangents, and this chord also has to be parallel to the other tangent. Now let's look at the second part of the proposition. The second part says, if QQ prime be a chord of a parabola bisected in V by the diameter PV, and if PV be of constant length, then the areas of the triangle PQQ prime and of the segment PQQ prime, parabolic segment, are both constant whatever be the direction of QQ prime. This is a little bit tricky, so just let's take it step by step. Given a parabola with PA as the parameter. Now what's the parameter of the principal ordinate? Now PA is what we would call latus rectum. In those times it was called parameter of the principal ordinate. So what is it actually? You take the focus of this parabola, it will be somewhere here, draw a perpendicular line, then the length of that perpendicular line inside the parabola is your latus rectum, or as here it is called parameter of the principal ordinate. Okay, and AH as the axis. Let AB prime be the particular segment of the parabola with vertex as A and AH is perpendicular to BB prime and bisects it. QQ prime be a chord of the parabola and let PB bisect QQ prime such that AH is equal to PV. Since QQ prime is being bisected, that means QV is equal to Q prime V. Draw QD perpendicular to PV. So here PV, if we extend it, we have to draw the perpendicular and join DV. Draw P such that QV square is to QD square is equal to P is to PA. Here we have QV, we have QD, we have PA. That means we have to find P, which we know how to do that. So let's do that. Now, as we saw, PA is the parameter of the principal ordinate, that is latus rectum, and P is equal to the parameter of the ordinates to the diameter PV, that is those parallel to QV, and this is based on F proposition 1.49 of Apollonius of Perga. Now, since now we know that P is equal to the parameter of the ordinates to the diameter PV, we can say QV square is equal to P times PV. PH square is equal to PA times AH, which means now here QV square is to BH square is equal to P is to PA. How did we get that? Here, based on construction, we know that H is equal to PV, right? So that means QV square and BH square are the same multiple of P and PA. So we can say QV square is to BH square is equal to P is to PA. That means BH square is equal to QD square. Again, see here, QV square is to QD square is equal to P is to PA. And here we have QV square is to BH square is equal to P is to PA. P is to PA is common. So that means QV square is to QD square is equal to QB square is to BH square. So again, we have QD square and BH square being compared to the same magnitude, that is QV square. So that is how we can say that BH square is equal to QD square. Now, since the squares are equal, that means BH is equal to QD. Let's multiply both sides by AH on this side and PV on the other side. Remember, AH and PV are both equal to each other. So if we multiply like this, the equality doesn't change. So BH times AH is equal to QD times PV. BH times AH is what? BH times AH. If we form a triangle ABH, BH is the height of the triangle and AH is the base of the triangle. We know the area of the triangle is half of the base into height. Now, if we double BH to get B prime, we will end up with AH times B prime. Similarly, QD is the height of the triangle PQQ prime. So let me draw that. And this is the ABB prime. Now here, PQV triangle, if we look at, QD is the height of the triangle and PV is the base of the triangle. So, which means that triangle ABB prime is equal to the triangle PQQ prime. And since the triangles are equal, so the segments are also equal. ABB prime the segment of the parabola is also equal to the segment of the parabola PQQ prime. So if QQ prime be a chord of a parabola bisected in V by the diameter PV and if PV be of constant length, remember PV is equal to AH, then the areas of the triangle PQQ prime and of the segment PQQ prime are both constant, whatever be the direction of QQ prime. Here, one additional thing that I would like to mention is how can we say that triangle ABB prime equal to triangle PQQ prime means segment ABB prime is equal to segment PQQ prime. That is because segment ABB prime is equal to 4/3 of triangle ABB prime and segment PQQ prime is equal to 4/3 of triangle PQQ prime. So that was proposition number 3 of works of Archimedes, specifically from on the conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.